this is our agenda today. So, we are going to go over this drunkard problem. So, this is a little bit longer problem, but we will go over all of it. So, okay. So, basically we call this the jaywalking, right? So, you randomly walk and then that is how kind of a drunkard walk. There may be some influences sometimes, right, but usually it's kind of random. You can think of it as such, right? So if you want to simulate, then you can actually use simple random number generators. Okay, first is the single movement, right? So part 1, you have to there's certain amount of pixel number for a single step, and it's actually first move random amount of between 2 to 5, right, random steps, and then it actually choose to turn. Okay, so not the other way around. Okay, so that both going forward random amount and then turning randomly is considered a single move. Okay, so you have to first write that function, and then you basically need to simulate the whole process until it code, right? So the criteria for turning is given, right? So it doesn't it has to be like a certain direction, so those directions are given. So one option is not to turn, and then you can turn left and then turn right, and then the other one turn back. Basically either way you can turn 190 degrees. Okay, all right. And then you are asked to get one step like 10 pixel, but you can actually make it a parameter. Okay, and then drunkard start and at 0 0. Okay, and then there's a circular boundary with a known radius. Okay, and basically you can think of, okay, outside there's police, and then you get caught when you cross the boundary. So it's a circle, right? So, and then there's a condition to be inside the circle and to be outside the circle. What's the condition? To be inside a circle, what's the condition?
To be within the radius.
Yeah, so basically the distant mode should be like a displacement should be less than or equal to the radius of the circle, right? So that's the condition. So basically, and you can say that until basically he stopped. So basically when he stopped, when he crossed the boundary, right? So that's actually going to be the condition. Okay, all right. So let's what are the inputs of this?
Step size.
Yeah, step size, right?
The turn actions.
Those things we need to calculate inside.
Okay.
Okay, so right now it's
Amount of steps taken, or you don't know that yet?
No, we'll calculate that, right? Yeah. So output is going to be the single single move, but you also need to return the 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 distance travel in that single move, right? Because I think in the improvement I asked to calculate the distance, right? So that's the total distance, but since you are going to run the single move in a while loop, like in a loop, then you have to accumulate. So that means your single move function must return the distance travel. Okay, so this is gonna basically its output going to be that so and then the single move distance of single move. Okay, so that's need to output. Okay, so we can easily visualize this right here. So I'm going to actually dump this one and show you guys again. So imagine we our turtle is right here at 0 0. Okay, so right here. Oops, okay, so I'm gonna delete that. So turtle start at 0 0, and then it actually moves, right? So basically it's a first random amount of steps, right? So let's say that random amount is like 3 steps, right? So we go, this is 1 step, 2 and 3. So now it's actually making a turning decision, right? So basically turn, let's say I need this one, sorry. So right, so so now it's taking a turning decision whether to not to turn or turn left, right or back, right? Let's say now it picked turning left by 90 degrees. Now it's looking at this direction, right? So now it's basically it need to go randomly few more steps, right? So let's say 2 steps right here, and then turning likewise. So likewise, you can go like, it's kind of random pattern, right? like this and this and this, like this, right? So that's basically the all movement. And basically if this is the radius, right? So I'm going to now draw a circle, right, and centered again right here. Okay, so and then basically so it's also centered at 0 0, and then if it cross right here, then basically it's going to get caught, and then that's when it's actually going to get stopped. Okay, so at this point, right, so I'm going to draw a small circle over here. Okay, so at this point um, the distance the displacement, sorry, displacement it traveled is equal to radius, right? So this distance is radius, right? So from here to here, this is radius. Oops, right? So this is radius, right? And then so this distance is basically, I'm going to take a different point. Let's say this one, and that's actually, let's say x comma y, right? That's x comma y. And what is this distance from here to here? What is that distance? This is x comma y. How do we calculate that distance from here to here? So this is 0 0, this is x comma y. How do we calculate this distance? What is the theorem? Theorem?
Square root of x2 minus x1 squared plus y2
Yeah.
plus y1 squared.
So what's the theorem?
The distance formula?
There's a theorem. Yeah, it's a distance formula, yes, in Cartesian coordinate system, right? So what does it's based on theorem, right? What theorem? Math theorem in math? Yeah, that's the one, right? So, and we know x. So, right. So this is 0 0. So I'm gonna move it over here, right? So that means this distance is going to be. So the general formula is x2 minus x1 to the power 2 plus y2 minus y1 to the power 2 square root, right? But since x1 and x comma y is 0 0 here, we'll end up, right, x to the power 2 plus y to the so to the power 2. This should be to the power, and then the whole thing square root. Okay, whole thing to the power 0.5. Okay, that's square root. So this is this distance. Okay, all right guys, so basically, and then this distance. Okay, all right, so when this distance become equal to radius, right, that's when it's going to get caught. Okay, so that's the condition. So this kind of, this circle is a hypothetical circle. You don't need to draw this. Okay, so draw the circle. All right, so yeah, so okay, so let's write the plan for this one. The plan 1, move one step and turn. All right, so we're going to input the step size. Okay, so we need to so the next step is basically we move forward random distance, right? Okay, so and that going like, you know, going distance, we need to actually book, like, you know, bookkeep that value, right? So single step distance equals, and we can calculate that randomly, right? So right, so basically equals random number between 2 to 5 times step size. Okay, so okay, this whole thing, just gonna put a bracket. All right, then we'll have to move forward, right? Move forward by this amount. Okay, okay, so now we are ready. So now we moved, right? Now we are ready to turn, right? So that means, right, so how do we do that? So we need to calculate our criteria. Oh, by the way guys, we didn't talk about matches, right? This one has really good matches, really good match. What is it? And there's couple actually. We are creating criteria, right, to check. So we end up creating criterias in the past. What were those problems?
We did it with the gambling one.
Yes, yeah, that's a good match. Yeah, but turtle wise, right, there's a random popping shapes, and also rock paper one, right? That's also a match. Okay, so term popping and rock paper and gambling. All right. Okay, so now we'll have to create random choice, right? So random turn choice. All right, so it basically between I would say, like, you know, get a random turn choice between, so there are 4 choices, right? So I would say, like, you know, 1 to 4. So now we are ready, right? Okay, so now we can actually write the criteria. So if, right, if random turn choice is 2, so this again, it depend on you know, so this is my choices, yours may be different. Okay, so 5.1, I would say turn left by 90. Okay, and oops, yeah, and 6 else if, right, and this one again, so I would say if it is 3, you're going to turn right by 90. Okay, and then step 7, and if this is 4, right, turn back, right. So basically turn left or right, right, by 180 degrees. Okay, and what should be the last step? Oh, not last step actually, yes, one more, right. So step 8, so the else scenario is basically not to turn. How do we not to turn? Oh, how do we do that actually? So, well, we'll have to, with this logic, we'll have to make a turn, but so turn amount should be 0, right? Turn n direction by 0. But I think if you use independent if, then you don't have to do anything. Just leave it there, but need a random number of 4 choices, right? So else 8.1, turn right, I would say by 0. Okay, so we are not turning. Okay, all right. So what's the last step? What should be the last step? Step 9. No, this is a single move, right? Single move is one move randomly and then turn. That's it. This is a single move.
I thought it said to take another step.
No.
Oh, oops.
So first the remember the criteria, right? So it's basically so this first, before making a turn, move randomly random amount and then take one of these, right? That's a single move both.
I misread the next paragraph, the take one step, like 10 pixels long. I
Okay.
thought that meant take another step after.
Oh, okay. So that's actually the step size.
Yeah.
Okay. All right. So so but there's one more step, which is basically we have to return the distance. Okay, single step distance. This is also a variable, and that require a second function to calculate the total distance. Okay. All right. So let's write this code. Let's translate this one, and that I think name the function like this. You can, in your plan, you can give it your function a name over here on the top. So that's what I did over here. Okay, so I recommend doing that. So def, and then the inputs are these two, right? So step size, and then we need actually the drunkard as well. So that's an input. All right. So all right. So I would say the docstring moves the drunkard, which is this single random move, right? Okay, something like that. By a single random move and move of step size, no, maybe and then the return the distance. I would say 4 step size. Okay, so okay. All right, so step 2, single step distance, this one. Okay, so can copy paste, and I'm gonna call a random number there. Okay, so this one is a random number, right? So random, what should be the method? And int, and then between 2 to 5, right? Time step size. In the next step 3, right? So now we have to move forward by that distance, right? So drunkard dot forward by single step distance. All right, so now we have to create the random choice, right? So random turn choice. That's another random rand int call. I would say like 1 to 4. So we need 4 choices. Okay, and then other if condition. I'm gonna simply copy paste. Okay, and change. It's really close to English. All right. Okay, so and it's 2. This is turn right, left, and elif and basically, oh, this should be this left virus. So drunkard dot left by 90. I'm gonna copy paste like this. Right, this is 3, turn right. Okay, and then the next one, that is 4. Okay, so sorry, so this is 4. And we're going to basically turn, let's say turn back, right? So this would be 180 degrees. Okay, and then else basically turn, let's say right by 0 degrees. Okay, and in the end return the single step distance. Okay. All right, let's give it a try. But I think if you use independent if, you can actually omit the last one. Okay, so why I cannot omit in this form? Then if I omit this one, then I have to make this else. Then basically else scenario now include 4 and 1 both, right? So that's not gonna work. But if you use independent if statement, for statement, and then you can actually do so. Okay, all right. Yeah, so we call this function and the step size, let's say 20, just to show. Okay, all right, so 93, oh, elif line 93. Oh, it's not is actually. Okay, it should be 2 and then it's equality check. Is an operator, but we basically check the identity using is. I think we didn't go over properly, right, on is. Okay. So maybe next week I can show you the is operator, but it's not in. Yeah, Cybook didn't cover that, but it's a good operator to learn. Okay. So okay, so random choice equals 3. What is that? Did I make a mistake? Probably this one. Right. 95 now. Yeah, I think the same issue. 99. Name. Okay, names. Oh, step size. I think. Oh, this should be this, right? Okay. All right. So it should run now. Yeah, there you go. Okay. It's kind of. I cannot show you right now. So it's really fast, and you can see like it goes somewhere and then now ready to go to the next move, right? So something like this. Okay. So it's a single move forward and then turn, random turn. Okay. All right. So let's do the rest. Okay. So now this is a single move, right? So the other one, plan 2, should cover the simulation should cover the entire movement. Okay. So for this one, so we have step size and also the radius, right? So drunkard, so radius of boundary. Okay, so this one. I think that's all. That's the input. For this one, we need to actually accumulate the distance, right? So there are two things, right? One is the displacement, which is this one, right? That's the displacement. So we'll probably every time we'll get something close to whatever this radius, right? Not exactly, but really close to, because that's when we end the while loop. But that's displacement. Distance is the sum of all these distances, right? So that's going to be a higher number. So we need to accumulate that. Okay. So right. So so I would say initialize the total distance to be 0, right? So we need to initialize that. Okay. We also need to calculate the displacement. Okay. Displacement, that also 0. Okay. So now basically it's a while loop, right? So what should be the condition?
While the turtle is within the radius.
Yeah. So while the displacement, right, is less than or equal, right? So less than or equal to this guy, right? So what do we do?
Run the first function.
Yeah. So basically this guy, right? Move one step. So it's 4.1. So are we done here or
No, because we haven't updated displacement.
yeah, so we need to update both the distance, right, total distance, and the displacement, right? So otherwise it's going to be a, you know, if we run is like this, then it's going to be a infinite loop, right? So we need to update two things. We need to accumulate the total distance, okay? So total distance, okay? So this guy returns that one, right? So do this, and I would say accumulate. So what happened? Okay, right here, right? And accumulate. Oh no, I'll check spelling. Um, let's see which one. Total distance. Okay. Sorry. Yeah, total distance. Or maybe and add to, right? Add to total distance. Okay. Then we need two updates. One is so that's actually the distance update. The other one is step 2 is actually so this kind of, this one has two things, right? So because function returning the distance, and here basically we need to update the displacement. How do we get the displacement? How can we find this last position? How do we find this last position? We need to find that position to find the displacement, right? Yeah, there's a subtle function for that. It's actually POS. This one. Yeah, that also works. Position basically returns the coordinate pair as a tuple. Okay, so you can actually use that. Okay, so basically I'm going to it's a tuple. So I would say, like right here, calculate displacement. Okay, if you want, you can write the formula, like also the position one, but this kind of, it's a vague step, right? So basically there's some math over here, right? So you can, if you want, you can write that down as well, right? So I can actually get it from here, right? So let's see if it's by this. Okay, so still vague because what is x and y? It's still coming from the position command, right? Position, yeah. Okay, and that's the while loop. So that's basically, now it's a last step. What should we do? One thing we can do is we can if we want, we can actually print. Remember, this in turtle mode, print function doesn't work, right? So you can actually use the turtle write function. Okay, write two things, right? One is this total displacement, right? So displacement comma total distance. Okay, you can write that right there. Okay, and I think that's about it. Yeah. Okay, all right. If you want, you can also return that two thing. Okay, and then you know, write it in the main program. Either way is fine here. Okay, okay, all right. So let's write this code. Okay, so def simulation. So this one has two inputs, step size and radius. Okay, and then this is basically runs the drunkard We need drunkard as well, right? So we need drunkard. Drunkard simulation for these two. Okay, or you can say until it crosses this boundary. Okay. So the next step is we're gonna initialize total distance and displacement. So it's gonna be 0 because at the beginning it's actually at 0 0, and then the displacement also going to be 0, right? I'm going to change this. No, I think I can just. All right. Less than or equal this, right? And we're going to call that function, right? So that function is basically, now we can create a variable, and then I think we create a variable. Yeah. So total distance equals to the call of that our first function, right? So we are accumulating that. Oh, did I start? Yeah. Okay. All right. Okay. So next step is to find the position, right? So this is the update basically, right? So we have to calculate the displacement. So that equals basically, so we have to generate a variable like, you know, like coordinates or position equals drunkard.pos. So now this is a tuple, guys, okay? So that means in your calculation you have to use the indexes to access x comma y, okay? So displacement equals and it's a square root of, right, and then here it's x means this guy's 0th index, right? That's going to be x coordinate to the power 2 plus 1 to the power 2, okay? So this is y, okay? All right, and then basically you in the end of the while loop, you use the write function dot write. So that's how you print to the screen, and you write this okay, this one, and total distance. Oh, this should be plus equal, right? It's accumulation, right? Yeah. So total distance, I would write this one first. Displacement comma well, yeah, this should work. I mean, I think you can pass many. Let's see. And the total distance. Okay. All right. So let's try this one now. Simulation. All right. Let's see. Okay, line 120, step size not defined. I think it's yeah. Okay. So let's say like 20, and this one is 200. Probably this is too much, so let's say 10. Okay, so it's now working. Oh, it's actually only ran. Did we make a mistake? So let's try it one more time. No, just random. Yeah, this one gonna be a while, I guess.
I was gonna ask them. We did some assignments, but you never graded them.
Which one?
I think I redid like the
So, and you can see over here that kind of, they're both together, right? So they're crammed up. So I think we'll have to change that the way we write over here. So I would say we need to basically do this. Yeah. So it's a tuple. It's passing a tuple. Okay. There you go. So we have, it's still we need to format this input. So I'll do so when I post the code, guys. Okay. So you can see over here my the one I wrote earlier. I think right here. Right. I actually did so, like, I formatted that output so you can see it clearly. Okay. So I also returned the 2 as a tuple. So you can do both actually. Okay. All right. So let's answer those questions. All right. Write the relational Boolean operator and the respective operands you use in your code. So there's a whole lot over here, right? So these are all relational operators. Okay. And then there's a one over here as well. Okay. And there's a one over here too. Okay. And then if we take, okay, if I take this one, what are the operands? Line 93. If I take that one, what are the operands?
random term choice.
Yeah, this one is the first operand, then the second operand, right? All right. Write a module name and an attribute of that module that you used in your code. Well, it's a random module and attribute is random randint. Okay. But you can also pick turtle module as well. So we have several attributes. All right, 2 keyword type tokens you used in your code. So there's if, here, elif, while, right, else. All of those are keyword type tokens. Write a formal parameter use and then respect to argument, actual parameter. So what are formal parameters over here? Yeah, these are these two, right? And then I think they are the same. Oh, in the call, if I take this 2 and this 3, right? So right here, drunkard and 1020, or the actual parameters of 200. Okay. Oops. Okay. Write a Boolean expression you used in your code. Boolean expression. Okay. What is a Boolean expression over here?
Displacement is less
Yeah, this one, right? This is a Boolean expression. And here also we have 4 Boolean expression, 3 actually, right here, one, this one, this one, and this one too. Okay. All right. So any question on this one, guys? It took a little longer. This is a little bit long problem. Okay. And you can see that, right? So over here in down below, right? So this is 230, right? It's not 200. Why is that?
Because he keeps moving. He keeps taking his steps
Yeah, while
until
yeah. So and basically the thing is when we check the condition next time, at that point it's actually already outside the boundary, right?
you check
So
the condition. He's inside the boundary.
yeah,
He takes his steps.
yeah,
And he keeps moving until
yeah.
he's done.
But if we do this, right? So it's because we are doing the move after the like before the displacement calculation, right? But if we do this first, right, we will probably end up more accurate. Okay, so sorry, right? We'll be a little bit accurate if we do this way because we are now calculating the distance before we make the move, right? So we might be a little bit accurate, but it's still because there's a random amount of steps, right, involved.
It'll now be smaller, right?
Yeah, a little bit, I guess. Yeah. See that? It's now
Yeah, it's close.
2-0. It's close, right? So again, it's still more because random amount of move involved, right? Yeah. Okay. All right. All right, guys. So this is our. All right. So today, so we actually just encountered this today, right? So we had a nested function call, right? So we defined this function, right? And we call it in here inside the loop, right here, right? So so we call this nesting. So basically that's how you break down a big problem into pieces and then put them together. So sometimes we call, and then you will see that in this video you will hear the word wrapper function, and this is a kind of wrapper function. We call this like remember we when we talk about that function at the very first lesson, right? Function must be only a single task, right? Must solve, and then function's name should represent that, express that task, right? So it's really important that you do that. If you do other things beyond that task in the function, now there's going to the name going to be confused, going to create a confusion, right? And then this video actually nicely going to talk about that. Okay, so let's so I just published it in module 11, guys. Okay, so let's preview. All right. All right, guys, let's continue. So we're gonna go to our lesson. Okay, so what is static typing? And Python is dynamically typed language, so it's good to understand the difference. It's a really common interview question actually. What's the difference between dynamic and static typing?
Static typing would be when you can't change the type of a variable versus
Okay.
dynamic typing when you can cast it as different types.
Yeah, so you basically you can change the type, but to be able to use a value or variable, you have to predefine the type of that variable, right? So that's the static typing. Basically, the programmer explicitly has to define the type of a variable or value even before we use it. Okay, so dynamically typed languages like Python, basically Python figure out the type dynamically of the variable, so you don't have to actually write. So for example, right? So if we go over here, okay, so let's say age, okay. So in a statically typed language, right? So statically, so we would run this one, okay. Let's say if I want to age, um, define a age. So in Python, we can simply do this, right? But in Java or C++, you will have to have like int the type like right here, like something like this. Okay. So this is the type that we are predefining the type of the variable. Okay. So Python, you don't need to do that, right? So basically, then how does Python figure out the type? Okay, so well, regardless whether statically typed or dynamically typed, all language figure out the type of the variable it's going to use. It's pretty much a basic requirement in coding for programming. So then how does Python figure out the type?
Based on the characteristics of the data.
Yeah, so based on the value itself, right? So here basically Python C, like 40, it's just 40, no decimal point, no quotation, right? So that means basically it knows that, okay, there is an integer, right? So that process takes some amount of time. So that determination take a little bit of time, and that actually slows down the entire language. Okay, so that's one of the reason that basically the main reason why Python is slow compared to pretty much every statically typed language, including Java, C++, C, all of those languages. Okay, so because every time you encounter a variable, it end up checking the type of it first, and then it takes time, it adds up. Okay, so that's a significant amount actually. Okay, so so let's go back. So because of this dynamically typed reason, so you don't have to actually have your in your function definition also, you don't have to define a type for that. So that enables, for example, so define some functions to be able to take variety of data types. And if you take this example, so like so this is actually running in Python tutor, right? You can see that we are adding two things, right? X and Y, right? And you know that if it's X and Y two numbers, we can add them, right? But you can imply addition. If both are text, then we can imply it's a concatenation, right? So but the things, because we don't have to predefine a type in the definition, we can actually use to our benefits, and we actually call it having many types. That means polymorphism. So let's take let's run this code, right? So we are calling the function. First we are calling the function for two numbers, right? So we get the sum, right, like 12 here, and then the next one call goes for, like, we are now passing two strings, right? So it's now adding the concatenating the two strings, right? So we get Tora Bora. Okay, so so this basically now a single function can do two things, right? So basically that single function, we say, have many forms. So poly means many, right? Morphism means forms. So that's why polymorphism means kind of like having many forms. Okay, so in here we have two forms. So basically function, single function acting like two ways. One is to add numbers, the other one is to add concatenate strings. So that feature in programming we call polymorphism. Okay, and then in Python it's basically inherently built into the language. Okay, for other languages like Java and C++, we'll have to explicitly define our data structures and variables to be able to achieve polymorphism. But in Python, it's sort of like built in, okay, to the language. And then one reason for that facility is due to dynamic typing. Okay, All right. So let's continue. All right. So we say, everything in Python are objects. So that means that includes functions as well, right? So how do we, how can we check for that, whether functions are objects or not? Ideas? So I'm going to copy paste that code and then we're going to run it. So how can we test whether a function is an object or not? We know that, like, we we know that if it's an object, it should be in somewhere in the memory, right? So we can actually check for that. Okay. So for example, if I actually uh, print this function, just the name of it, add, okay, we'll get something like this. And then you can see that, say, this function, the name, and then we have the type of object, which is function. So we call it the function object, and this is kind of a proof. Okay. So if I create a list and then did this, right, and we say it's a list class, right, it's a type, and then basically comes after that the name of the function, and then basically at means this is the memory address where it's located. Okay, the function object is located. Okay. So this is kind of proof that, yeah, functions are also objects. Okay. And then it basically it's stored in the memory as bytecode. So it get converted to bytecode and then stored. Okay. There's some bunch of errors over here. Okay. So that's some common mistakes that you can may encounter. Okay. So one is copy paste error. Okay. So pasted code, not properly modified. Okay. So that can happen. And the return errors, right? So right. So for example, right, if I take this, I think we encountered this already, but it's good to go one more time. Okay. So for example, if I take this function, so I'm returning now from this, right? For example, I'm going to just print, right? Print the result. Okay. And you can see that it's actually work. Okay. So I'm gonna add, I'm gonna call this one for, let's say 10 and 30, right? I'll see 40, right? Okay. But the thing is, I'm not returning from function, so I will not be able to use the function itself as an expression. So for example, let's say I have two other numbers, right? So other numbers which I need to add, and then I need to calculate the sum of it. Okay. So let's say this is 20 and then 30. Oh, sorry, like this. So this is 50 and then 50, 40. I should be getting 90, right? But instead, what I will be getting?
40, 50.
This one?
Because it prints out. Oh no, it would be 40 then 50. Wait, no.
So first one gave me 40, but this should give, I mean, we are expecting for 40 plus 50, 90, right? But will we get 90? Why not?
because it's not returning anything.
Yeah, so this is a type error, right? So it's type error, and then you can read unsupported operand types for plus, right? See non-type, right? See that I'm not returning from my function, right? I am returning, I'm just printing. So return value of print is what? None, right? So it's basically you cannot add two non-types. It's not defined in Python, right? So this is a type error, right? So that's why it's return type error. But the actual reason is I I printed the value instead of returning. So strive to always return from your function, always. Okay, so that's a good thing. And sometimes there are special situations in which, like for example, turtle ones, we usually don't return, right? So you may just print, but usually it's a good thing striving to return from your function. Okay, all right. So that's the return errors. So let's do this one together, guys. Okay, so using the days to minutes function as a guide, organize the lines of code to create a modified function name named minutes to days that converts minutes to days. Okay, so that's an example over here. So if the input is 1.5, then the output is 1.5 days is this much, likewise. Okay, all right, so let's see. So what do we have to do here?
Find the function.
So it's a drag and drop thing, right?
Yeah.
So what we should drag and drop?
Define minutes of days.
This one, right? Where should it go?
Yeah.
Right here? Okay.
Oh no. Define minutes of days.
Right here?
No, you grabbed hours equals.
Oh yeah, yeah, sorry. Yeah, it should be defined. Okay.
Yeah.
All right. Then
Uh,
it should convert the hours, minutes to days, right?
yeah.
So
it should be minutes equals hours times 60.
so
Hours equals value minutes divided by 60.
this one, this one, okay,
I think.
and then that just gives you hours, right? Then
Then day days equals hours divided by 24.
this one,
Yeah.
okay. Is that all, or
And then return days.
return days, right? Okay,
Yeah.
that's it, right?
I think so.
Okay. Yep, yep. All right. So let me see. I think I stopped the previous class at this because this we should have a lengthy discussion on this topic. We watched a video already, right? So I encourage you guys to re-watch that video. Okay. So this is an important topic, very important topic, and then for especially for beginners, it's a confusing and challenging topic. So I would say I'm gonna finish with that topic, this module on Tuesday. Okay, so let's do something because we still have some time. Something. So it's return errors. We covered that. These are just activities, right? Yeah. Well, let me open the problem today, guys. It's this one. So you're gonna reverse a list. So I just published it. It's actually due 25th. Okay, so this actually not updated right now. Yeah, so this one. Okay, so I just published it. So you have to reverse a list manually. Okay, so can't use reverse method. There's a built-in function called reverse, right? You cannot use that, as well as you cannot, there's a way to reverse using slicing, string slicing, no sorry, list slicing. You can use that as well. Okay, so basically you have to do it manually. Okay,